to basically accreditate themselves. Unfortunately, in many colleges and universities, software testing as a skill is not addressed near to the degree that it ought to be, though there are now some residences where in various colleges that do teach software testing as a practice. There are hundreds of magazines. There's millions of software testers out there. There's in fact a crowd-based software testing that folks just put software up on the internet and people try to break it. So software testing runs the gamut from very general to very specific, and from very complex to somewhat simple, just basic UI type of testing. Software testing is at least as much an art as it is a science. And while those of us who have been in the software testing industry for quite some time, like myself, and let me take just a moment to neglected to earlier mention that I have been in the software testing industry for about 20 years, both as a practitioner, as a tester myself, as then into automation, performance engineering, software test manager, had spent several years consulting for very large companies, and then started a company myself during the Y2K years, and with a successful company in software testing. Now I run the Tempo Test Labs, which is a nearshore software organization providing testing services and development services for companies. So with that said, software testing isn't as much as an art as it is a science, in that software testers, and this is where I think generally they consider themselves at times second-class citizens of the software engineering world, in that they don't necessarily have the technical expertise that a skilled software programmer would have, but they have a different set of skills that are vital to producing high-quality software. And that is that at times that they intuit, they understand where defects are likely to be found, and they have their own bag of tricks, and they have their own way of looking at the world. If a software developer is a builder, then a software tester is the destructor. He or she is the one who tries to take and dismantle something apart. And I guess this is historically why software engineers and software test engineers and software developers sometimes don't get along, is because the activity of software testing has the intent of breaking something. When a software tester picks up Visual Studio 2010, they're going to look at it as a piece of software that's going to help them, enable them to intentionally attempt to make things go wrong. They're going to do something intentional. They're going to try to determine how to break a piece of software, how to cause it to fail. Now, if you're a developer and you're building a piece of software, one of the last things on your mind is to put your code through extraordinary measures in order to break it. You tend to take a more happy path to do the things that it should do, and you don't try to use destructive testing or stress testing or performance testing or all the other types of tests that can be done in order to prove that a piece of software is working correctly. So the software tester and the software test engineer sometimes can be antagonistic. The beauty, in my opinion, of where Visual Studio 2010 lands is it brings together these two disparate groups and it tries to help them to work more in harmony. And they do that by sharing the same code base, by sharing the same defect, by being able to allow the test engineer to help the developer to successfully reproduce a bug, so that there's now this reduces the antagonism. So in a word, the world of software testing is a large and varied world. It's estimated to be a $57 billion industry, and is growing at an annual rate of about 9%. So it's a very large industry that is only slated to get larger and larger, especially as software continues to be more complex and deployed on more diverse machines, and as our world gets ever more dependent upon software. So the world of software testing is going to be a component that we as resellers will need to understand in order to successfully meet the needs of our client and really to understand what their world looks like. And so this one slide is all we're going to take on describing the activity of software testing, though it could take weeks and weeks to really dive deep into it. We're going to move now on to some of the more potentially obvious, but just I want to make sure that there's clear understanding of why software needs to be tested. There's a lot of folks that resist the fact that software testing is a necessary practice. But because of at least these 5 things, and because we see so many failures of software, it's becoming more and more accepted and less obstructionistic that software needs to be correctly and thoroughly tested. At one point, it was that if there was a budget constraint, that the software testing activity would be lessened, and that's no longer, at least less true. So there's 5 primary components for why software has bugs, and so then why it needs to be tested. First is miscommunication, and each of these, Visual Studio 2010 addresses each of these head-on. The miscommunication comes from a lack of transparency and a lack of shared data, which is solved in 2010, Visual Studio 2010. Software complexity is going to continue to increase, and by streamlining the way that the software is designed through Visual Studio 2010's components as well as tested, it is going to be a solution for folks. Programming errors, changing requirements, time pressure, all these things have a bearing on software being able to be effectively tested, as well as why errors have occurred in software. And each of these requirements have been addressed, or each of these aspects have been addressed in Visual Studio 2010. There'll be more on this in the session number 3 that we're going to be talking about this specific area in more depth. Software is never going to be free of defects, regardless of how much testing is done, and testers often ask how much is enough, and management asks, why do I even need a piece of software that will assist my test engineers to test? The fact is that a defect-free application is not possible because it's created by human beings and because of just the nature of the process of creating software. But our goal as software professionals is to reduce as much as possible the defects, and to that end, that's where a software test professional comes in. So their job is not just to find defects, but to also to help to prevent them. You can see from this chart that the defect average is one defect per 100 lines of code, and so or for function points. And so if you extrapolate that out, some of the large pieces of software are ridden with errors, and many of them don't show up until the most inopportune times. On the previous slide, I skipped over fairly quickly, but there were descriptions of major catastrophes because of a software flaw, and we're all aware of those. And so, again, all of these things point out the need for effective software testing that leads to higher quality software. Now, we're going to go to school just for a little bit here so that you become somewhat conversant with the basic terms in the software testing world. This is by no means an exhaustive list, but as you become more familiarize yourself with some of this terminology, you'll be better able to relate and understand what the needs of your clients are. So you have the artifacts within a software testing practice would be a test plan, a traceable matrix, test cases, test scripts, a test suite, test data, test harnesses, types of testing. Folks, these are the 4 general categories. Each of these would have 5 to 15 different subsets of the kinds of tests that you can do in each of these. For an example, an acceptance test is the kind of test that is done at the very end of a software development cycle, whether that cycle is 2 weeks or 2 months or 2 years. And it's typically done by an end user. And these kinds of tests would be somewhat simple tests. It'd be user interface tests to ensure that it matches what the requirements were. But it could be a fairly in-depth test as well of a load or regression test done during the acceptance phase. So I mention these four because you're going to hear these terms, and we should all be understanding these terminologies. Now let's go through them a little bit more in detail. So as I mentioned, an acceptance test is a user verification of the initial objectives and expectations. A set of requirements hopefully was written so that they understand what the software is supposed to do. And based on those objectives and those expectations from the shareholder, that you derive a set of acceptance tests. Acceptance tests can be a long period, could be a short period. In an agile world where the development cycles run from 2 to 4 weeks, the acceptance test could just be a couple of days. In a longer or waterfall methodology, it could be weeks, and back and forth it can go. Tools are generally used during the acceptance test, and that's primarily would be an automated test. And what they would perform is a basic set of regression tests that test the basic functionality. Let's go to the next one. As I said, I don't want to get too pedantic here, and I want you to understand this without getting too in the weeds. An automated test, that speaks for itself. That's basically a test that is implemented by software or script without human intervention. And these tools are extraordinarily valuable, especially when it comes to adding new features. What you'll do is you create a suite of tests that exercise the application based on a certain endpoint. And then when new features are added, the automated tests are run against that entire new suite to make sure that the new features have not introduced any new bugs or any new defects. And this can be an extraordinarily valuable time saver. The issues is that often the automation scripts themselves are somewhat brittle, and as the software changes, they haven't been created in a modular fashion. And so the flexibility of Visual Studio 2010, when you are addressing that with your clients and customers, is a very flexible piece of software that can create automated tests in a wide range of modes, from very modular to end-to-end, and everything in between. Manual testing is typically carried out by a person. That's what we would have called a generalist tester. The manual testing, the exciting thing, and this is something else enforced again and again, is the tools within Visual Studio 2010 are addressed specifically to the needs of the manual tester. The manual tester does not like repetitive testing, but often is relegated to carrying it out. So there's a function called Fast Forward within Visual Studio 2010 that allows the